we've covered displacement and velocity, we've covered acceleration. Now it's time for our final topic, falling objects. Let's take a look. So, situations with falling objects tend to combine elements of displacement, velocity, and acceleration. So let's take a closer look at the acceleration component of that. So here on the surface of the Earth, all objects fall with the same constant acceleration. This value is known as g. It's the acceleration of an object due to gravity. So for a downward direction, we're going to say g is negative because this is for things falling and gravity is causing things to fall. Negative 9.81 meters per second squared. That's just the universal value of g. We often round to 10 meters per second squared just to make calculations simpler. And keep in mind that gravitational acceleration is constant during upward and downward motion because we're always on the surface of the Earth. So if a person throws a ball over here, acceleration due to gravity is always going to be the same. It's always going to be g everywhere. So it's definitely easier to grasp concepts with falling objects through some practice problems. So we're going to look at this first situation. A ball is tossed upward. What is the magnitude of its acceleration? A, during ascent, B, during descent, and C at the top. So let's label this. We have A over here, it's ascending, B, it's descending, C, it's at this topmost point. So as you may have already noticed, this is kind of a trick question, because as I mentioned on the last slide, acceleration is the same everywhere on Earth. So during ascent, it's going to still be accelerating with a rate of negative 9.81 meters per second squared. During descent, it's going to be falling, so that's negative 9.81 meters per second squared. And even at the top, the force of gravity is still acting on the object, and it's still going to accelerate 9.81 meters per second squared, because it does so everywhere on the Earth. Practice number 2 for falling objects. A rock is dropped from a cliff, and it strikes the ground at 30 meters per second. How high was the cliff? So we're looking for this value, x. That's the height of the cliff. So again, we haven't mentioned anything about time, so we're going to go back to this equation, v final squared equals v initial squared plus 2ax. So we know the v final, this is 30 meters per second at the bottom. 30 squared equals, v initial was 0, it's dropped, that's the key word there. It starts from rest, plus 2, acceleration, we're going to treat gravity as 10 for right now. It'll just make this problem easier to solve. And x is what we're looking for. So now we can, simplify this a little bit. 900 equals negative 20x. Divide both sides by negative 20. And we see that x equals negative 45. So what this really means is that the displacement of the object is 45 meters downwards. It's fallen 45 meters. So what does this tell us about the height of the cliff? Well, it was dropped 45 meters above the ground, so the height of the cliff is 45 meters.